I would like to explain how we could in the deterministic automaton for this non-deterministic automaton. It is called the observer. This example is extracted from the textbook Cassandra's and others from figure 222. As you could see, this is the non-deterministic automaton. It is non-deterministic because a specific event like B can lead to two states from one, either one itself or zero. And also we are having the empty transitions epsilon and epsilon. Okay, these are the so this is the null event. Null event can lead to state change. So we need to see how to construct this observer from this one using JFLAP software. As you could see, I have already started the JFLAP software. It has multiple options. We will use the first option, which is the finite automaton. I will just left click on finite automaton. Then I will start building the non-deterministic automaton. First of all, I will create the states. We are having, as you could see, we are having 4 states, 0, 1, 2, 3. So I will click on this circle and I will left click also here. It will add a state called Q0, Q1, Q2, and Q3. In order to have an identical naming, I will rename the states. I selected this arrow and then I right click on Q0 and I will set the name. It will be just 0 and I will click OK. The same also, right click, set the name, it will be 1. Right click on 2 and set the name, it will be 2. Right click on Q3 and set the name, it will be 3. Okay, so we have created the states, but you should take into account that state number 0 is an initial state and it's also a marked state. This could be also identified here. I will mark it as initial. So once it's marked like an initial state, we have this arrow, it's a very big one. And to mark or to identify it also as a marked state, we will mark it, or we will select final. As you could see, the boundary has been doubled. Now we will add the transitions. So we have a transition from 1 to 0. I selected this arrow and I will add the transition. That the event for this transition is B. We are having another transition from 0 to 1 and its event is A. Okay, now in order to have the identical shape, we can just, as you could see, you can just drag or we can reshape. So for instance, if I click on the transition A or even the transition B and I drag from this circle, it is dragged above. And if I click on A and drag from the circle down, it's dragged down. Okay, fine. Now we will add the self loop for B, again using this arrow, the self loop for 1. Okay, I just double click again on 1. This is the arrow and I'm double clicking and I'm writing a B. Okay, that's all. And then I'm adding another transition from 1 to 2. And this is, by the way, the epsilon. I will just write enter. Okay, this is the empty event or the non-event. And instead of epsilon, we are having here a lambda. I will repeat it again from 2 to 3. I will add another transition from 2 to 3. I will just press enter. It's an empty string, so it will be just lambda. Again, we can add another transition from 3 to 0, but it is not empty this time. I will write B, and then I will add another transition from 2 to 0. It will be A. I believe we have completed the automaton as listed in the figure. Okay, so it is time now to construct the observer. I will just select, as you could see, I will just select convert it to a deterministic finite automaton. We can just write this to be complete. He completed the automaton. Okay, now we should try to verify whether this is identical to what we have reached or what is listed in the textbook or not. We could compare them together. As you could see, we are having here the state 0, 1, 2, 3, 0, 1, 2, 3, okay. The state 0, 1, 2, 3 here you can have two events A and B, transition B, and two transitions in opposite direction A to Q0, so it is exactly the same. I will select here done, and he will open it in a new window, and I can save this for future working. Thank you very much.